Hello everyone. This video is on the Knewton Alta assignment for section 3.1 part 1 called Relations and Functions. Alright, so in this video I'm going to be going over a preview version of this particular assignment. Please understand that the questions I see in this video may not be the same questions you see when you work on the assignment yourself. But all the objectives are the same, so the questions should be similar, and hopefully watching me do these here helps you in some way when you're working on it on your own. Alright, so here's your assignment page. You got the title, you got your mastery bar, telling you how far along you've gotten. Got your objectives. Looks like there are 3 objectives in this assignment. Under the current objective, there should be a question related to that objective, and at the bottom of every question should be a feedback button where you can send feedback to Knewton. You will not have this instructor cheat button, right? This is for instructors only, but you will have a more instruction button where you can, if you're struggling with a topic, you can click on this. It'll take you to some reading, some videos maybe, and then you'll have questions related to that reading or those videos, and you can work through those and get through the assignment that way if you wish. Alright, so first objective here is determine whether a relation represents a function. Alright, so the question is, in which of the relations represented by the tables below is the output a function of the input? Alright, so first, before I get into this, let's talk about that. What does that mean? What does all this stuff mean? Alright, so first off, a relation is just a correspondence between 2 sets. So let's say this circle here represents one set, say set A, and this circle over here represents another set, set B. And, elements in one set, let's say I represent some elements by dots, and there's elements in this other set, and, we'll draw arrows to talk about relationships. Say this element here is related to that element and that element. And this element here is related to this element over here, and this element's related to this element, and that element, and so on. Right? Now, usually it's just represented by ordered pairs, so sometimes you might just see this referred to as a set of ordered pairs. So like x comma y, right? You've seen ordered pairs on graphs. So if you see an ordered pair, that just means that element x corresponds to element y, right? X from the first set corresponds to y from the second set, right? Now, a function is a special kind of relation. It's a relation so it's a set of ordered pairs, right? But it's a special kind, right? It's a relation where each element from the input set, which we'll call this first set here, input set, and then over here the output set where the elements are mapping to. So each element of the input set corresponds to exactly one element of the output set. And it's got to be exactly one, no more than one. Okay, so this picture I have up here would not be a function, because you see this element here from the input set maps to two different elements in the output set. That's not a function. Alright, so this example up here would not be a function. It's a relation, right? And any correspondence between two sets like this is a relation, but a function is a very special kind of relation. Alright. Okay. So an example of a function would be like, say here's the input set, here's the output set. I got these elements over here in the input set, these elements in the output set. If this element corresponded to just that element, and this one corresponded to just that element, and this one corresponded to just that one, this would be an example of a function. Right? Every element in the input, input output again, but every element in the input set corresponds to exactly one element in the output set. And that's it. Alright, that's all you really need to know to help you get through this assignment here. So back here, looking at the input and output element, now look at this first one. You see how the input of 9 shows up twice? So input element 9 corresponds to two different output elements. That's not going to happen in a function. Right? 9 maps to 0 and to 3. This one, you aren't seeing the same input more than once. So each input goes to one output, and that's it. Right? So this is a function. Here, same thing. You're not seeing any input more than once. So every input goes to exactly one output. Right? So that's a function. This option, right, again, you see the input of 9 twice. 9 goes to 12 and 9 goes to 0. That's not going to happen in a function. Right? Still a relation though, right? But it's not a function because of this input element of 9 going to two different output elements. So that's not a function. I'm not clicking on that one. And then the same thing for this last option. You see the input of 6 twice. See, the input of 6 goes to two different output elements, and that does not happen in a function. One more time. A function, every input element goes to exactly one output element. Alright, so the only two I've clicked on are the only two functions listed here. Great. And again, please, now after every submission, it's going to tell you if you got it right or wrong. And then you're going to have some answer explanations. Please read through the answer explanations just to understand maybe why you got something wrong and maybe learn for the future. Alright, next question. Alright, we're switching objectives. It says identify the domain and range from a set of ordered pairs. Alright, so the domain and range are just the words for these input and output sets. Right. So the domain of a relation, alright, the domain is the set of inputs, which in an ordered pair, that first value in an ordered pair, the first coordinate, is the input value, right? It's coming from the input set, coming from the domain. And the range is just the output set. Right? It's just the set of all the outputs. Which, typically the inputs are x coordinates if we're talking about ordered pairs, right? And for the range, the output values are these y coordinates, the second coordinates. That second coordinate is coming from the output set, coming from the range. So it's typically y coordinates, right, are going to be the values in the range. So again, something you've probably seen before, a pretty simple concept. So here, find the domain of this. Now they're telling you it's a function. You see -2, that input goes to -6, and I don't see any other inputs of -2. I see -9, -4, and +8. And basically, it's a function because none of the inputs are going to more than one output. Right? Negative 2 goes to negative 6. That's it. Negative 9 goes to negative 12. Negative 4 is input, goes to an output of 6, and that's it. 8 for input goes to negative 10 for output. They ask us for the domain. The domain is just all the input values. Negative 2, negative 9, negative 4, and positive 8. So that would be this set here, right? Negative 9, negative 4, negative 2, and positive 8, right? This is the set of all the input values, all the x coordinates. That's the domain. Right? And that's it. All right. Next question. Now they want the range. What's the range? Now remember, the range is all the outputs. And there's no need to repeat them. You know, if you see the same value more than once, don't write it more than once in the range or the domain. All right. So the range is, has negative 10, negative 12, negative 4, and negative 8. Well, that looks like this set here. This set contains all those values: negative 10, negative 12, negative 4, negative 8, and they just put it in order, least to greatest. But that set has all the second coordinates, the y coordinates, the outputs. That's the range. All right. Wonderful. All right, next question. We're changing objective back to that determine whether a relation represents a function. So it's just like the first example I went over. Once again, we're given a input-output tables and saying, is it a function or not? So here, every input shows up once. So every input goes to one output. This is a function. Here, same thing. Every input shows up once. All right, there's no repeating input, so every input goes to one output. That's a function. Same thing here. Now, in this part, see 0, the input of 0 goes to two different outputs. Goes to negative 5 and positive 2. So that's not a function. Same thing for this one. The input of negative 4 goes to two different outputs, 2 and 6. Right? So that's not a function either. Every input should go to exactly one output in a function. Okay, great. All right, next question. All right, so this is use the vertical line test to identify functions, right? So far, the functions we've been seeing have had, 4 ordered pairs, 5 ordered pairs, 6 ordered pairs, whatever. But most of the functions you're going to be seeing in the rest of the course, and that you've seen already, you've actually seen examples of functions. I don't think they just weren't called functions before. Most of the functions you're going to be coming across have infinitely many ordered pairs. And so instead of listing them, you're going to be graphing them, drawing a picture of all these ordered pairs. All right, so let me talk about the vertical line test. So if you're looking at graphs of relations, remember x values represent domain values, y values represent range values. All right, so the horizontal axis represents possible values from the domain, and the vertical axis represents possible values from the range. I'm going to put up 2 examples of graphs here. And I'm going to ask, in which one of these graphs is y a function of x? Right. So you see in this graph, every single x value I pick goes to one y value, right? This x value goes to this y value. This x value goes to one y value. This x value goes to one y value. Basically, if you were to draw any, every x value kind of corresponds to a vertical line. Right? This x value corresponds to this vertical line. This x value is on this vertical line. This x value is on this vertical line. So here it is. If every vertical line you draw, straight up and down, hits the graph at most once, right? Over here, these don't hit it at all, right? That just means that x value is not in the domain. If you draw a vertical line and it doesn't hit the graph at all, that just means that x value is not in the domain. But if you do draw a vertical line and you hit the graph, that means that x value is in the domain. But if every vertical line intersects the graph or hits the graph at most once, so 0 times or 1 time, hits the graph at most once, then it is the graph of a function. Then we would say y is a function of x. Or you could say that it is the graph of a function. Right? Basically, when I say y is a function of x, that just means every x maps to one y. Every x corresponds to exactly one y value. And this is called the vertical line test right here. All right. Now, if this fails, like look over here. Say this graph here, all these ordered pairs. Pick this x value, right here. See how this maps to this y value and this y value. So there's an x value. There's a value in the domain that goes to more than one value in the range. That's not a function. Well, look, if I draw a vertical line that x value is on, see how it hits the graph more than once? So here's the other part to this. If a vertical line, all you need to do is find one. Here it was every. Right? If a vertical line hits the graph more than once, then y is not a function of x. Alright, this is kind of like the second part of the vertical line test. Right, because if you draw a vertical line that hits the graph more than once, that means there's a value in the domain that maps to more than one value in the range. There's an input value that maps to or corresponds to more than one output value, and that doesn't happen in functions. Every domain value should map to exactly one range value in a function. Alright, so if we go back here, which of the following graphs represent functions where y is a function of x? So look, any vertical line I draw hits this graph once or 0 times, at most once. So this is a function. Y is a function of x here. Here, this line, just follow my cursor up and down, I'm hitting the graph twice. Over here I'm hitting the graph twice. So I can find a vertical line that hits this graph more than once. This is not a function. Y is not a function of x. Here, every vertical line I draw hits this graph either once or 0 times. So this is a function, at most once. Same thing here, function, right? Every vertical line I draw hits this graph 1 time or no times. Alright, so every value in the domain is only going to go to one value in the range. That's a function as well. Great. And again, check, the not a function, function, read through the answer explanations. Okay. All right. Next question, same objective. Again, just which of the following graphs represent functions? Once again here, look there's a vertical line that hits the graph twice. If you can find any vertical line that hits the graph more than once, y is not a function of x. This is not a function. This one is. Every vertical line I draw hits the graph either 0 times or 1 time, but no more than once. This is getting hit twice over here with a vertical line, so that's not a function. And this one's getting hit either 0 times or 1 time. This is a function. Y is a function of x, right? A very simple concept, I feel. All right. And moving on. All right, so back to just domain and range. Remember, domain is a set of all the inputs, all the x coordinates. The range is a set of all the outputs, so the y coordinates. Right? So they just want the domain first. So that's -5. And seriously, just says, and now they have the set brackets, so you don't have to put the set braces up. You just put the numbers in there with commas, separated by commas. So I'm just going to put all the x coordinates, -5, comma, +8, comma, +1, comma, and then +11. Now if you want to put them in order, you can, but those are in the domain. Those are the x coordinates, the inputs. And then they should have a thing about the range next, right? Find the range of this function. Right? So again, they have the braces up already. We just need to put in the numbers, that are in the range, separated by commas. So the outputs, the y coordinates, -8, comma, -9, comma, -11, comma, and 1. And once again, if you see the same number twice, don't write it twice. There's no need to repeat numbers. If it's in the set, it's in the set. All right. But none of these repeated, so that was it. Great, easy enough. So that domain and range objective is done. So now we're back to the objective, determine whether a relation represents a function. Back to these tables, very simple I feel. Remember, in a function, every input is going to correspond to exactly one output. That is not happening here. The input of -1 goes to 2 different outputs. That's not a function. Here, the input of 0 goes to 2 different outputs. That's not a function. Here, the input of -1 goes to 2 different outputs. That's not a function. Here, each input is showing up 1 time, and so every input goes to 1 output. That is a function. Same thing for the last one. Great. Okay. All right, so one more like this. Determine whether a relation represents a function. Okay, so in the relation in the table below, write a value that will make the relation not represent a function. So, really you could put in 7, 0, or 4. It'll take either one, any one of those, because if you put in 7, then 7 would go to 13 and to 3. If you put in 0, 0 would go to 6 and to 3. If you put in 4, 4 would go to 11 and to 3. So if you put in 7, 0, or 4, it should be correct. All right, I'll put in 0. Right, a value. It didn't say put all the values, just put a value for the question mark. That will make this not a function. All right. So again, see, it's taking all 3 of them. 7, see, 7's an answer, 0's an answer, 4 is an answer. That would make this not a function. Any other number, and it would be a function. All right, so that objective is that objective's done. And then back to the very pretty simple, in my opinion, vertical line test. Every vertical line hits this graph once or 0 times, so that's a function. Same thing here, function. Same thing here, function. This, there's a vertical line that hits this more than once, so this is not a function, and I'm done. Very, very easy in my opinion. And then we should have just one more like this. Not a function. Not a function. I see a vertical line that hits this more than once. Function, right? Every vertical line is going to hit this once or 0 times. Same thing here, function. real easy. And that should be it for this preview version of this assignment. Okay, and as I said at the top of the video, right, the questions I saw here may not be exactly the same that you're going to see, but the objectives are the same, so the questions should be similar, and the way you do them would be the same, right? Would be hopefully watching me go through these examples here help you in some way when you do it on your own. And thank you very much for watching.